It's an order From immediately, I requested on the dice to light the lamp which is symbolic of the knowledge spirituality. Kindly rise. Thank you. Education is sorry, and a happy life is one spent between learning and learning for more. I request the convener of ICTIR 2022, Professor Satish Kumar K, to read the report of ICTIR 2022.
Good morning, everyone. This is honored after the years. I am truly honored and privileged to stand before you to brief the third international conference on technology for industry 4.0 revolution by ICTIR 24, which is being organized by the Department of Electronics and Communication Engineering and Electrical and Electronics Engineering Department. ICTIR stands for 24 stand for Technology for Industry 4.0 Revolution. The objective of this conference are manifold. First and foremost, we aim to foster global collaboration and exchange of ideas on different topics such as IoT, deep learning, artificial intelligence, wearable, big data, and blockchain, and electrical vehicles, and so on. Secondly, our goal is to empower participants in knowledge and tools that can apply in their respective fields. Lastly, but certainly not least, this conference is an opportunity to collaborate diversity and inclusivity in academia, research, and beyond. We have received certain number of research-oriented technical papers such as E&CE card, predicting academic performance of engineering students, reverse vending machine, and human service robot, etc. E&CE has a card. E&CE has a card can be used to store patient health information so that he can control his health through this technology. Another paper titled Predicting Academic Performance of Engineering Students in India. Nowadays, AI and artificial intelligence and machine learning technology play a major role. This paper investigated the use of machine learning techniques to predict the academic performance of the engineering students. Another paper is human vending machine for plastic. Next, development of humanoid robot utilizing Arduino, Mega, Nano, Euro, and classified. And it's a humanoid robot which recognizes face, gesture, and emotion. Another paper titled A Study on Implementation of Memories Based on Work Cycles. I conclude this report by wishing good luck for the paper presentation. Also, I thank the management and institution for being an opportunity to organize this event. I also thank Dr. Srinivasa and Dr. Ramakrishna for being the president of the function. Special thanks to our chief guest, Dr. Krishna Reddy, who was being my colleague in DEPT Engineering College. At present, he is working as technical product manager in E&CE. Thank you, everyone. Have a nice day. Submit class.
Thank you. I request Professor Rakesh Pandya, Assistant Professor, Department of ECE, to hand students in Dr. Krishna Reddy, HOD, Department of Automobile and Aeronautical Engineering, Srinivas Institute of Technology. Thank you, sir. We feel honored to have with us Dr. Krishna, a man of distinct vision and focus ideas and knowledge, experience, and inspiration to all of us. I would like to request our chief guest, Dr. Krishna Rai, to address the gathering.
Am I audible, sir? No?
Yes, sir.
Okay. So, good morning, all. First of all, I would like to thank Srinivasa Institute of Technology and all the staff members of Electronics and Communication Department and Electrical and Electrical Engineering Department for organizing this wonderful event and inviting me as a keynote speaker for this interesting conference. First of all, I would like to thank all the organizers of this team for considering me for this event. So when Professor Satish approached me, I wholeheartedly agreed to be part of this event. So I think this conference is happening frequently. I don't know, but I urge all the staff members and the management to keep conducting this kind of conferences frequently, so that students get opportunity to interact with the industrial people who are from the field with the experience. They interact with the staff members and also with the students, so that we can exchange knowledge. As you heard from the conference theme, a lot of interesting topics were presented by Professor Satish on the deep learning part, AI part, and automation part. So these are some of the most happening things in industry, where we are focusing now mostly into the automation side, where we can automate entire software development process, testing process, workflow part. All those things are getting automated. So I think a lot of focus being given there. And being the electronics and communication engineers and electrical engineers, you should have a strong foundation of your subjects, whatever you study in your colleges. They are the foundation. Those foundation is very important to build the additional knowledge, whatever industry needs. So sound knowledge of those topics are very useful. Like for example, if I take the example of my own industry, which is GE Healthcare. Healthcare is like intersection of multiple subjects, where it includes biology. You need human anatomical knowledge, biology concepts, and you need physics knowledge to understand all the modalities, scanners, how it is being designed, the physics part of that. Mathematical part is I think it's most important part. For everything, you need a mathematical modeling for designing the things. So mathematical concepts also very important. And then all the basics what you study in your engineering syllabus. So they are also very useful, like digital image processing, signal processing, all those things. And then coming to the additional skill set what you gain on the programming side, C, C++, or Java, or all the latest, greatest tools, they all are very useful to develop the products. So finally, whatever you learn there should be getting into the products, right? So you're going to develop some of the important product which is going to play with the lives of the human. As you know that healthcare is the most important area which requires a lot of attention. When you design any software for healthcare, it should take care of the patient's life, right? So it's going to play with the life of the people. So you should have safety aspects, security aspects, cyber security aspects, and then you should have FMEA kind of concept where you do the safety assessment of all the component where you design to develop the product. So those are some of the important areas we should focus, like cyber security, one of the important area. You might have heard of a lot of incident happening in the cyber security where they're attacking the hospitals and getting the data access, and privacy is one of the important aspects of healthcare, where patient privacy should be retained, where you're not supposed to disclose these data as per governance by the country. So these are some of the important aspects you should build knowledge along with your academic subjects. So this may not be taught directly with the part of your electronics and electrical subjects, but these are some of the laterals which you should learn from outside, where you get a lot of materials, online courses, those kind of courses you should undergo and gain those knowledges to get into the field. So those are very important. And as you know that G is one of the important, one of the conglomerate where we are working on multiple divisions. Healthcare is one of the division. We have avionics, which works on the aircraft engines, and we also work on the turbines. We also work on the train-related manufacturing, energy. Those are the different sectors we are having. But recently, GE got split into multiple smaller companies, and GE Healthcare has become one of the independent entity now. So we are focusing more on developing product in the areas of healthcare. So presently, I am leading the MR product initiative. As you know that we have multiple scanners from getting developed from GE Healthcare. It can be X-ray or MR or X-ray, MR, and CT. Those are different scanners we are developing. So I lead this MR product here in GE Healthcare. So all those subjects what you studied there are really being used here for the manufacturing of the scanning equipments. So you should think from the system perspective. So you should have system engineering knowledge, and you also need a software engineering knowledge and hardware, firmware. So when you say system, it's the integration of multiple aspects. So there's a piece of hardware coming into picture, and there's a firmware which communicates between the hardware and software, and also the pure software part which controls the entire hardware aspects. And then we have multiple internal components like reconstruction, and then host control part, which is a workflow orchestrator. Those are the different aspects of a system. So when you develop such system, you need the knowledge of entire hardware, software, firmware, and then software engineering thing. So mix of all those things results in development of wonderful products. So with that small context, I would like to urge you all to focus more on your studies, have a good foundation of your academic subjects. These are whatever you're studying there is just 30%, 30 to 40% what you study from the syllabus, what college can teach you. Rest of the 60% should come out of yourself. So you should have that urge to learn new subjects and explore new areas, and go outside and get that knowledge from the experts, interacting with the industry people, or going to the industry, doing some internship activities, and then getting into a lot of innovation activity, taking part in hackathons, and then reading a lot of literature, journals, and then participating all the conferences, whatever you're attending now. This kind of conference really helps you in getting those additional knowledge needed for making you 100% ready for industry. So with that thing, I would like to request all to focus on those areas, and don't just stay with the marks what you gain in the colleges, but additional thing is also very important for the present trend to survive in the industry. So with that, I would like to again thank all the conference organizers for inviting me as a chief guest. And I'll be talking more regarding the healthcare, the industrial example of healthcare, how your electronics and electrical things are getting used in real industry. I'm going to present for next 45 minutes after the event. Thank you all. Thank you, sir.
Thank you, sir. The leader takes people where they want to, whereas a great leader takes people where they don't necessarily want to go, but ought to be. As voted by William Martin, I request our dynamic expert, Dr. Sharkey, to address the gathering.
Respected President of the Function, Dr. R.K. Hegde, our Chief Guest, Dr. Harish Rai, my colleagues, and students. Today we are in the inaugural third international conference, Technology for Industry 4.0 Revolution, that is ICTIR. This conference is organized with the intention to update knowledge as well as to publish the work on the latest trends. Today we are having with us Dr. Harish Rai, Technical Product Manager in Healthcare. In his keynote address, he is going to enlighten us about the advances and recent trends in medical imaging. In this competitive world, to survive, we have to update knowledge on latest trends and happenings in the outside world. These type of conferences will help us to know where we are and where we have to go. Thank you.
Thank you, sir. Before you are, success is all about moving yourself. When you become a leader, success is all about moving others, as voted by the prayer. Now we request Dr. Sharkey, HOD, Department of Engineering, to address the gathering.
Good morning. The chief guest of today's inaugural conference, Dr. Harish Rai, Technical Product Manager, E&CE. Head of the department, Electronics and Application. Head of the department, Electronics. The convener of this third conference, ICTIR 2024, the participants and faculty members and their students. So first I'd like to congratulate the complete team, the whole team, and the two other departments for putting a lot of efforts to make this conference possible. The third one is ICTIR 2024, the team on focus on industry 4.0. So looking back to this industry 1.0, so it all started with seeing the industrialization with manual state handling of major machines like rails and data. And ultimately, the concept of mass production came, and it was produced by another than before. And this period was regarded as industry 2.0. And further advancement led to automation and semi-automation of systems in industries. So one point is say that like electronics, computer science, etc. And of course, giving a lot of opportunities for the engineers from those departments not the concept during industry 1.0. and further advancement like to say artificial intelligence. And nowadays, most of the industries, the top industries, they have embedded in their not only the industries, but the whole scenario has changed nowadays, and this context, the conference is organized, providing a lot of opportunities from the research area, especially in this in the profile of the chief guest itself. So this is one of the fantastic fields where a lot of innovations are possible, and especially for the research student or in research. Focus on research, the student who are looking for startup ecosystem. So this is one of the area where you can focus on, say, biomedical or medical field and use your same embedded concepts to further improve by innovative technologies. The theme of the conference is covering a lot of same areas, and it is expected that not many tables come when we conduct the conference with the tag international. So it is expected that it's to be on the whole team, the organizing committee. The main role is played by the convener, but it is the efforts of the organizing committee to bring lot of say papers of occupation, especially in such platform conference. Otherwise, it will definitely meeting. So when a lot of say contributions come in automatically, this platform is so open for say any type of discussion, collaboration, and taking the research at the next level or any type of guidance. Some things will happen. You have plenty of papers in a conference. So it is not difficult. At the same time, the institution is supposed to focusing on the quality. So IPS is there. The principal, the chairman of the IPSC. It is, of course, giving guidelines, framing the rules and regulations for the departments and not to compromise the quality of any activities they are conducting. So quality, when it comes to quality conference, ultimately, such conference should happen with the conference facilities. So I hope the efforts and attempt is made by the two other departments and by the conference convener to ensure that ultimately the facilities it is coming in our own form. With ISBN number, there is one step working on quality. Further, the quality is supposed to measure when you oppose set findings in the top journals, international journals of ranking. Of course, as per the guidelines, we are to be on access of. So at least what you should take care of journal is first when you find a place for publishing. And I don't think it is big enough to get the papers from our end. Only thing is the effort from our end should be more. And not only is the duty of the faculty members, but also the students can actually. So a lot of initiatives are there at the department level. So this is the right platform to convert that into publication. And definitely that is going to boost the department image, automatically boosting the institution's image and ultimately say getting the advantage when you go for national accreditation with A or A plus or A plus plus grading. When they are all interacting with qualities, then automatically the students, the alumni, they recommend the peers to get into this recognized institution recommendations or requirement. So it is, they are all the interpretation of those. So workers on the qualification must, and students should convert any findings of mini projects, and it, of course, it is the responsibility of the department level. Lot of mini projects and many projects we are doing. When the committee is there, project committee under the state purview of E&CE. So if it is giving trust of the quality of the project, all the projects or findings of the projects or paper, not only in the international purpose, but again we can publish it in a journal sometime. So recently we have conducted a seminar on components and language guidelines. And for your information, 52 papers we are publishing in Scopus indexed journals. 52 papers. This is apart from only conference paper from right. So if there is an effort, if there is an effort as well as the teamwork, a kind of coordination and power, a very good understanding involved the student also, then it's not a problem for getting many papers. So I again congratulate the organizing committee and the request the students to take the input from the chief guest, because this is the most happening field. He is of course focusing on this biomedical or medical related applications of engineering, and some of the fields for anybody student to start their own enterprise or startup system, ecosystem. The college and the institution has got its own startup ecosystem, and it is which is none other than Dr. Sri Krishna. Many startups have been registered, the small startups. So we are supporting the institution, supporting achieve money. Of course, we can ask from the management, right, to initially begin with. And we have to provide the opportunity and dedicated space for the students to even work beyond the hours. So please utilize such opportunities. Please, of course, not available in many institutions. I tell you, many institutions is not available or it is space focused. Take opportunities and come up with a lot of ideas, new ideas. And again, the institution council is there, ICTIR is there to guide the community to patent products or final product be launched in the markets. Like this is the ultimate goal of any student or any academy. So for the faculty members, my advice, I basically for the set guidelines for the faculty members to publish a paper, at least one paper. It's so much that I want to remind all the faculty members here. Please focus on this. Don't take it easily. And at the same time, make use of the students and motivate them to ensure that we get the requirement of publication. Because in the department, your department is, of course, very, it is, of course, the pipeline. That's the information received from the management and from the principal. LB accreditation is the next step for us. So if you want to be LB ready, these are the things we have to follow. These are compulsory to remember in other colleges. Of course, SIT is going to be soft. I would like to comment. SIT is going to be soft for this, but in other institutions, it is a must. Right. With this point, I again thank the teachers, Dr. Hari Krishna Rai, product manager, G Healthcare, spending his time, address the students after this inaugural function. Thank you, sir, from the Department of Electronics and Communication, as well as from the institution, technology, and we are looking for kind of collaboration with you in the coming days. So, Sri Krishna will be in touch with you, and not only this keynote address, probably we are expecting, but also take the next level so that the industry knowledge will be imparted and the students will be benefited and the students will be motivated. They get some idea what to do that is ending up with say patents or products which will help achieve also. And thank the organizing committee. Please focus seriously on the platform given to the departments, especially the international conferences. This is happening only once in a year. Time bound once this conference is over today or Monday, you have 1 year of time. Remind 1 year of time to plan your course of action for the next year. So it should not happen 15 days before. Remember, it is international conference. I want to repeat, international conference, not to be taken so lightly. Thank you.
Thank you. At times, our own flag is out and is taken by a spark from another person. Each of us has fortunately with deep gratitude of those who have lightened the field within us. I would like to request Professor Tanapati Sharma, Associate Professor, Department of Electrical and Electronics Engineering, to deliver the vote of thanks.
Good morning, respected dignitaries on this. It gives me an immense pleasure to deliver the vote of thanks for this event. I would like to thank our chief guest, Dr. Harikrishna Raj, Technical Product Manager, GE Healthcare, who honored this function with his inspirational thoughts. Thank you, sir. My heartfelt thanks to President of today's function, Dr. Ramakrishna and Hegde, HOD Automobile and Aeronautical Engineering, for his support. Thank you, sir. I would like to thank Dr. Srinivas Vayandi, Principal Srinivas Group of Technology. In absence, due to busy schedule, he is unable to attend his function. So we remember his support. Thank you once again, sir. One sincere thanks to Dr. Surya Krishna, HOD Electronics and Communication Engineering, for his presence. Thank you, sir. Special thanks, Professor Mukesh Sharma, HOD Electrical and Electronics Engineering, for his presence. Thank you, sir. I would like to thank Professor Satish Kumar, Department of Electronics and Electronics and Communication Engineering, and also convener of this conference, to organize this event very smooth and successfully. Thank you, sir. Now, I would like to thank our management who supported us and provided all facility. Thank you to the management. And all the participants from other colleges and our colleges, without whom this program is not successful. Thank you, participants. I would like to express my gratitude to all the deans and principals of the Spanish. Special thanks to HODs of various department, and also my heartfelt thanks to Professor Madhusudan and his team for telecasting this argument. Present media friends, I thank all the teaching, non-teaching, and technical staff who made this program successful. I thank Professor Bebita and Professor Tisha for wonderful lesson. I would like to thank all the students and other members who supported us directly or indirectly to organize this event. Thank you one more.
I request Professor Satish Kumar K, convener ICTIR 2024, to solve the dignitaries of this. Thank you, sir. We now look forward to reconvene shortly after the commence the keynote. Thank you, one and all. Please come back for the keynote session after the key break.
Please.
Yeah. ಇದು ಮಾಡಿ ಯಾವಾಗ ಮಾಡಿ ಬರುದಲ್ಲ ಧೈರ್ಯ ಇಲ್ಲ. You. See. What's the job?
Connect like this.
Each gathering in the corner for exciting welcome each of you to the inaugural the International Conference on Technology for Industry 401. To keep up with technology changes that are happening at a very fast pace today, the department has taken the initiative to launch ICTIR 2024. We are indeed honored to have the presence of distinguished academicians and leaders with us today. We begin the keynote address by our chief guest, Dr. Hari Rai, Technical Product Manager, GE&A. Over to you, sir.
Hello, am I audible, sir? Can we get started?
Yes.
Hello, am I audible? Can you please
Yes.
confirm?
Yes, sir. You're audible.
Okay. Can I start now, madam? Can you please confirm if I can start my session?
Yes.
I can't hear you.
Hello, can you hear me, sir?
Hello, can you hear me?
Sir, I can hear you. Can you hear me, sir?
Your voice, I can't hear anything. Hello.
Sir, you may proceed.
Okay, okay, thank you. Okay. My voice is clear, right? I will start then.
Yes, you're audible.
Some network glitch. Yeah. Okay, welcome back and good morning again. I think due to some audio glitches, I could not hear some of the proceedings there. And I am extremely sorry that I could not make out for this event in person. So Professor Satish and Surya Krishna sir asked me to come in person, but I could not join this time because last week when I came to Mangalore for some other reason, but this week I could not come again due to some other issues. But anyway, I volunteered to give this session virtual, but I am hoping for in-person session in the future. Whenever I'm visiting Mangalore, I would like to visit your campus and meet in person and then interact with you all. I'll assure that I'll be able to help you in one more session if required in a face-to-face discussion. So with that, I think I would like to get started. So I think my introduction might have been given already due to audio thing I could not hear. Myself, Hari Krishna Rai. I am working as a technical product manager at GE Healthcare. And you will be knowing GE. GE stands for General Electric, one of the conglomerate. It works on the multiple industry sectors like aerospace, avionics, and finance, and then railways, energy, and a lot of other industries. It's around 16 to 17 industries. Some of the solutions being developed by our organization. And recently, GE Healthcare is split out of GE, and now we are the independent company. So this is started by one of the famous scientists, Thomas Alva Edison, in 1890s. So that is a historical background about GE. So this is a Thomas Alva Edison company known for his inventions. So invention is part of our gene in GE Healthcare, where we do a lot of latest and greatest technology development, innovation, and all the sectors we present and we develop products. So my organization, mainly GE Healthcare, is developing the products in the areas of healthcare. As you know, healthcare is one of the important sector, which is actually very critical and very important domain, because healthcare is very important for all of us. You know that due to the aging population and due to a lot of diseases prevailing in the society and a lot of issues, people get into health crisis one or other way in our day-to-day life. It can be a small fever, or it can be a small allergy. It can even go up to a very complicated diseases. So we cannot live without health. So health issues. So it's an integral part of our life. So we should be maintaining a good health so that you don't get into health crisis. We pray that you should never get into health crisis, because once you get into health issues, there will be a lot of challenges we face. So, so our company helps in disease detection and diagnosis, and also the disease management. So there are three things we do in the. If you divide the entire healthcare workflow, no, there will be a early part of the healthcare industry, which is mainly for disease detection part and the diagnosis part, and then the disease management part. So detection is mostly the scanning part, or it can be a radiology scanning, or it can be a laboratory test to confirm that people have the health issue. So we develop a lot of products related to this laboratory information system, LIS, and radiology information system, we call RIS, and then hospital information system, it's called HIS. So these are some of the verticals or healthcare sectors where we play in the different areas. So mainly the laboratory information system handles with all this pathology related things, getting the blood samples and then getting the detection of the some of the abnormalities with respect to the standards. So it handles that part. And then HAS is a hospital information system, which is mainly the hospital administrative aspect where the patient comes to the hospital, then the registration happens, they get the demographic data, and then they get the historical data, because most of the healthcare treatment depends on your historical data. What was your symptom? What was the indication you have? So based on that, doctor try to prescribe some medicine. No? So that is where HIS is very important to capture all the patient demographic data, starting with your age, name, and allergy matters, and what are the tablets, medicines you are taking. All those things will be captured as part of HIS software. So it's one of the big industry. A lot of companies are working in the HIS sector. If you want to name maybe, yeah, I'm still in the introduction part. I'm in the first slide. Yes, I'll come to the main subject. So HIS is something very entry level thing where all the administrative aspect happens. Then comes the RIS, the radiology information system. That's where the medical imaging plays an important role in the radiology information system. So this is the main department within the healthcare where all the scanning happens. It can be a smallest X-ray scan, or it can be a... No, I'm not changing the slide. I'm yet to change my slide. I'll come there. So radiology information system is the area where we play in this company right now. So my topic is mostly related to radiology related topic today. So advances in medical imaging and industry perspective. So in this, I am going to cover some of the important modalities we have, which is available for scanning and diagnosis purpose. And then at the end, I'll also try to cover some of the latest AI-based tools and techniques which will help the radiology for detection of the diseases also. I'll just quickly brief on all those things. So before getting into all these things, image processing is one of the evident and integral part of medical imaging. So that is why I want to start with some of the basics of image processing. So when I spoke to the professor, I came to know that we have students who are who might have not undergone the image processing or signal processing subjects. So that's why I'll just start with a small introduction to medical imaging in the beginning. So my second slide is visible. Can you please confirm why image processing is visible?
Yes.
Visible.
Visible, no? Okay, sure. Okay. So medical imaging, one of the interdisciplinary area we call medical image processing, because it involves some of the knowledge of your medical part, the imaging part we call biology part, the human anatomical parts, and then the human physiological aspects also you should know, and then biomedical instrumentation part we need, because we are devising some of the healthcare devices which needs all the biomedical instrumentation knowledge. And then mathematical part to do the modeling part, and then the algorithm development part, because most of the image processing algorithms needs a heavy math background, because without math you cannot do any algorithms, because whatever the subjects you undergo in your academics, you know, like it can be data structures or even the algorithms, those are very important to write important algorithms in imaging. And then even the software side, all the software engineering skills also very important, and then physics knowledge is also very important. So it's like an interdisciplinary area. It's a mix of all the knowledge is needed where if you want to become if you want to excel in this area. So the earliest invention of image processing started with for sending the picture information from Mars to Earth. That's why we started with the imaging importance, and then for all the printing purposes, display purposes. If you're virtually seeing me on the screen, it is all because of the image processing. What you can see here on the screen, I can see you and you can also see me. And then restoring the images is one of the important application where you can see the old image. If you have, you can, if it is degraded, you can do a lot of image processing techniques to restore the image quality. And then also extraction of the information. That is another important aspect where whatever the human brain which can read automatically when you see the picture, but how you make your computer to understand the picture. So that's where the computer vision parts comes into importance, where you can how you make your computer to read that image. Like when you see an image, you perceive certain information, right? Similarly, how you make your computer to perceive that information is all about computer vision aspect, giving a vision to the computer to understand the whatever the camera sees on the monitor. So that's why these all are very important aspects. And some of the examples, if you see the noise reduction, one of the important classic example, we can see that the salt and pepper noise on the left side being improved using some of the image processing techniques. Some of the fancy applications like morphing, face detection, all those things are some of the multimedia applications. And if you see on the last, on the right, bottom right, the 3D visualization where image processing is making you to look into the internal organs and see the what is actually happening inside the human anatomy is being visualized using the medical imaging algorithms. So these are some of the applications. I'm just running through these things. Healthcare, which I already told why it is important. Multimedia and entertainment also, it's one of the emerging area where a lot of advances are happening. And automotive for detecting the a lot of the road lane and then the collision detection, all those things are being used using computer vision and image processing in automotive. Satellite imaging, document imaging, all these are some of the classical examples, industrial imaging to do the field inspection and monitoring of the manufacturing process in the plants. All those things are applications where you can detect some of the abnormalities in the manufacturing process. And security and the surveillance, one of the classic example where you can see that you use CCTV to monitor the people movement, suspicious people movement, and then alerting. So these are very classical examples which you can see in the books also. And if you want to realize any imaging system, there are some integral parts you need to envision to realize a imaging system. It can be a medical imaging system, it can be a document imaging system, or it can be a satellite imaging, whatever it may be. These are some of the integral parts where you see that on the left, if you see the image acquisition system on the left side, which is mostly talks about the image capturing part, how you get the images captured using for example, the simplest image acquisition is your mobile having a camera, so that is one of the imaging acquisition system. Using a inbuilt camera, you're able to take a picture. Similarly, if you go to hospital, we have X-ray scanners, MR scanners, CT scanner, which are the acquisition system which takes the images. So basically, it takes the outside lighting things, and when the light falls on the object, the reflection comes out of that. So that will be sensed using the sensors in the camera, and you get the digitized pictures of that. You convert analog signal to digital signal using sampling techniques, and then get the image out of that in the image acquisition system. And then comes the post processing, where we do the image processing, because whatever the raw image you get out of camera or scanners, they may not be in a good condition to make your computer to detect certain information. So you need image processing, which will improve the visual aspects of the image so that you can detect that something using your eye. So that's why image processing is a crucial component in an imaging system. And then all the post-processing algorithm, it can be as simple as segmentation, detecting the boundary of a particular region. For example, if you want to detect a disease, how you detect the disease using some of the segmentation algorithm you devise. And then feature extraction, once you do the segmentation, you localize a particular region in the bigger image. You look at only that smaller subset of the entire piece, and then look at into a small region and get a feature extraction out of that. And then from that feature, we do the data analysis, the data analysis part using machine learning and deep learning techniques. We detect the patterns, and then the pattern gives the indication of what is actually the problem in the image. So that is one of the simplest example of a imaging system, which I want to bring here as a introductory part. So next comes just a funny feature to show that how will be the situation if there is no scanners, or if there is no medical imaging exist. How will be the situation? You would have encountered a situation where people would have manually cut open your human body and look at the internal organs. So you should thank our technology, the medical imaging technology, all the hardware, software part of that, which is helping us where you cannot, it's avoiding you to getting into the invasive surgery things. So we are moving from invasive surgery to the non-invasive surgery. When you say invasive, they usually take the scissors, knives, and then cut open the body part and then go inside and do the treatment. But now the technology is improving where you need not cut open any organ. So we have non-invasive techniques which are available in the industry, where you'll be able to use the latest and greatest technology like interventional camera, where you can, using interventional radiography, you can go inside the human body without cutting open. For example, as simple as if you might have heard about the cardiac cases where people get the cardiac issues, heart blockages, and you can do a angiography where they just to puncture your blood vessel and send a small tube balloon inside your blood vessel using the technique, computer imaging technique, where they do the guidance and navigation through the blood vessel. They go to the heart and then open the blocks in the arteries, because the heart attack happens due to the formation of the calcium plaques on the blood vessels. So we need to open that blood vessels, otherwise blood may not be flowing, which might cause a heart attack. So we use the non-invasive techniques to go inside the human body and then open the blockages and then give relief to the patient so that he will be survived of cardiac arrest. So this is some of the examples. So that's why we need to heavily use this kind of imaging techniques to get into the human anatomical things and get the picture of that. So now I'll go a little bit to small basics of image processing, because I don't know how many people might have studied signals and systems. These are very important subjects which comes in your maybe second semester, third semester, I don't know, signals and systems, and then the digital signal processing, and then the image processing, and then the advanced image processing. When we were doing our engineering, this image processing used to be an elective subject. I'm sure it will be, I think now it will be a mandatory subject in the academics. So signals, basically it's a signal which is a function which carries the information. So there are different types of signal: one-dimensional signal, two-dimensional signal, and three-dimensional, and also n-dimensional. When you say single dimension, one dimension, the signal varies in one direction only, in x-axis. If you plot, it will be variation in the t-axis. F of t, we represent a value of system at the time interval t0, that is f of t, like the t0, t1, t2, you can subsample. Based on the subsampling you do, get a continuous signal. So if you do the subsampling, you get a digital signal. So that you might have studied in your digital electronics also, the subsampling, the Nyquist criteria, why you should sample at the Nyquist frequency. All those things are very important to the digitization of the signals. And then comes a two-dimensional signal, where signal varies in x-axis as well as the y-axis. So you represent that function by f of xy. So one of the simplest example of two-dimensional signal is our image. So in the image, we have two variation. One is a horizontal scale and the vertical scale, and then f of xy is a pixel value. We call it as a picture element. It is the smallest unit in the image. The signal at xy means x can take a value of 0 and y can take a 0 of 0. So y can take 0. So 0, 0, you have value. Similarly, x can vary from 0 to 255 and y can vary value from 0 to 255. If you have a 256 by 256 image, we call it as 0 to 255 because there are total 256 intervals. So that's why it is f of xy, we call two-dimensional signal. And medical image, any image, digital image is a classical example of digital image. Similarly, three-dimensional, where f of x, y, and t, there is a third dimension where the time scale. If you are playing a video, you can visualize it as a three-dimensional. You have x and y as a still picture, and you are playing that in a different time interval, you get a video picture. So that's why it is three-dimensional, you can visualize. But in medical imaging, three dimension is differently perceived. I'll explain that in the later stages. And then we have analog signal and digital signal, which is digitized for a computer to understand. We have discretized the signals. And representation in the computer, how you store this two-dimensional data in the computer. You need, again, you should go to your mathematics, the matrix representation. The popular matrix is coming here, where you see that you have rows and columns. So we represent the image in terms of rows and columns, where M and N stands for the subsampling quantity, where M can take, for example, if it is 256 by 256 size image, so you have variation between 0 to 255. And similarly, in y-axis also, you have variation between 0 to 255, and you subsample the image and get the value at each interval. So that's where you get all the value of a comma 0 to 255, and a comma a of j varies from 0 to 255. We get a matrix representation, and value is stored there. So that's when you compute the size of the image. It is nothing but your number of rows into number of columns, and then how many bits you have allocated to store that value, because you need memory to capture that value, right? So we have B, which stands for the how many bytes you are using to store the image. It can be 1 byte image. If it is if you are subsampling the images of 256, you can take B of a 8-bit. It's 1 byte. And then C stands for the channels. We also use channels to store the image. For example, if it is color image, there will be RGB, red, green, and blue combination. So combination of RGB gives different color combinations. So that's why you need to know how many channels you're using. So it can be 3 channels of 8-bit each. So it will be 3 bytes. So if your width is 256 and L is 256, then if your height is N is 256, and if you have RGB image, it will be 3 channels. It is into 3 and then into 8 for 1 bit, 1 byte. So that is the total size. So this is a raw image, but if you do the compression, the size will reduce. And this is of the 3D concept, like how I told about the 2D image. When you slice it, when you stack it in a vertical axis in the Z direction, you get a 3-dimensional image where you can get 0, 0, 0, where Z direction also 0, that is the first image. And then 0, 0, 1 means it is the second slice, the first pixel. And then 0, 0, 3 means it's the third slice, the 0, 0th position. So like that, you get the stack of the image. You can visualize it like a bread slice. If you slice the bread, in Z direction, so your length will be the Z direction, then vertical axis and the horizontal axis will be X and Y. So you can visualize like a bread slicing if you get a 3D imaging concept. Okay, then comes the different image formats. We have standard for algorithm purpose. Researchers use a raw format. When I say raw, there is no compression applied. It is a direct data without any compression. And then comes a lot of compression techniques available, because due to the constraints in the storage and transmission, we need to reduce the data size as much as possible. So that's why we have a lot of compression techniques, starting from JPEG to JPEG 2000 and a lot of other loss and lossless techniques. And bitmap is one of the Microsoft specific image format. JPEG is the Joint Photographic Experts Group. JPEG is one of the multimedia purpose which is widely used even now in your mobile handset. If you take a picture, it is typically stored in JPEG format. So that is one of the compressed technique which uses internally DCT, the discrete cosine transform, to do the compression. Joint Photographer Experts. And then TIFF is also one document imaging format. GIF is also a multimedia format. JPEG 2000 is one of the highest compressed image. And then comes the DICOM, that is new to few of the people here. Maybe it is a very specific file format used in the medical imaging to store the medical data, medical images. So we call DICOM format. So DICOM stands for digital imaging and communication in medicine. So it is very specific to medical. So that's why this is not publicly known, but we use DICOM library to use. There are a lot of free library and also paid softwares are available to get the encoders and decoders of the medical images. Typically, we have extension DCM for medical image. So whatever the image you get out of the scanners are in the format of DCM, the DICOM format. So next comes the medical. Okay, before I get into till here, I just quickly ran through all the basics of some of the image processing. If you have any questions, maybe I can take now. Otherwise, I'll get into the medical imaging side directly.
Any questions, students?
If you have any questions on the basics part, I can directly get into the advanced part now. Maybe you can also use chat window if you want to ask questions, or maybe I'll move on. Maybe at the end we can take questions.
No questions. Sir, can you hear me?
Any questions? I can move on.
No questions, sir.
Okay.
So can you hear me?
Either you fully understood or you didn't understand anything. Maybe I assume you might have understood all the subjects, because this is a basics part which you might have studied in your earlier semesters, maybe third semester or fourth semesters. Okay, now I'll come to the little advanced concept, the imaging modalities. So when I say modalities, these are the scanners which is used for scanning purpose. Internally, all our imaging system, all our image acquisition systems. So this is an important topic, I mean, in the medical imaging, where we use this system for creating images of the human anatomical part, internal aspects. So we have, you can capture the images in a different frequency spectrum. If you see in the X-ray zone, also you can take in the gamma zone, also you can in the electromagnetic spectrum. No, imaging can happen in different spectrum. X-ray, you know the spectrum, and the ultraviolet, infrared, microwaves, radio waves. This is the classification of your EM signal. So depending upon that, what frequency range you are doing the acquisition of the system, we have different classification of the imaging modalities. The X-ray is a spectrum, you know, right? So X-ray is used for scanning of the bone and heart tissues. Similarly, the next one is a computer tomography. We call it as CT. This is also used for scanning the internal body parts, mainly for the bone and the internal soft tissue. And then comes the magnetic resonance imaging. So it is a MRI scanner, which is also used for internal organ imaging, where it uses a magnetic resonance technique to get the internal organ details. Then comes the PET, positron emission tomography, and then the ultrasound. So X-ray, I think it's a classical, I think you would have studied in the physics already, the X-ray physics is a basic thing which you study in your first semester, which was invented by Rontagen for getting the pictures of his wife's hand when she got into injury, and he got Nobel Prize for invention of X-ray. So X-ray uses radiation techniques where it emits the X-ray from the source. So there is a source and there is a detector, two internal hardware keys. The source emits the X-ray, and then the detector detects the X-ray out of the human body. So human is subjected to stand in between source and the detector. I think people would have undergone any bone surgery or bone fractures and all, no, during your childhood or any time you would have undergone X-ray. You would have seen this, how people take X-ray images. They will ask you to stand in front of a frame, or this ask you to lie on a table. So below the table there will be X-ray detector, and on the top you would have seen the source part. From the source, X-ray emits and it goes through the human body, and some of the X-ray things gets refracted and something reflected. So something gets penetrated through the human body and it goes to the detector. So due to the human body attenuation, no, the signal which goes from the source to the detector gets attenuated using the physics theory, the equation you can see here. So the degradation of the signal is due to the attenuation, because human body internally contains different types of structures. It contains water, it contains air, it contains bone, tissues. So all these internal structure, no, they have different X-ray characteristics. If you see here, air, you can see that a direct hole kind of thing where attenuation is low. And if you see the bone, X-ray attenuation will be very high. You can see that. And when there is no attenuation, you can see that it is completely, you're getting 100% signal out of that. But when the human subject is placed here, you can see that the top layer and the bottom layer, how is the signal getting varied. So due to this, you get the signal, which is the signal which got attenuated and which has passed through the human body, and it has come to the detector plate. So in the detector plate, they have detector elements which actually capture the signal, and then there will be a analog to digital converter which converts that into a signal, electrical signal. So that electrical signal is sampled, and you get a electrical signal, digital signal, and then digital signals are converted into images using the sampling techniques. So this is one of the typical X-ray scanner where the patient will be lying here, and this is the source where you can have X-ray source here. And here there is a plate, you can see that this is a detector plate. You can pull it out like a drawer, no? You can pull it out and get the digital plate from that. So earlier it was analog, now this is a digital plate where the moment you scan, no, you get a digital picture directly. And then from the digital picture, they can take a film out of that. So this is a X-ray principle. It works on the X-ray principle, and we get a very good images of the internal body parts. So this is a simple or typical examples of X-ray images, digital images, how actually images are getting captured. No, you can see that bone is getting more white in the things, and black is nothing but the cracks or things. You'll be able to see that wherever the abnormal things are there, you'll be able to detect that changes. Just for a minute, my headphone is having battery issue. I'll connect the charger. So, okay, I am back now. Okay, we are talking about the X-ray. You can see that fractures are clearly visible, and even some of the abnormal findings, like some masses are visible here, which shows that some pulmonary diseases are existing in this patient, where you can see that structures are differently visible due to the accumulation of the phlegm and all. That's why you can see different variations internal body. And it's mainly used for X-ray of bone, and then dental examination, and for the surgical masking purpose, and also the markers, they are used as surgical markers, and then orthopedical evaluation purpose, chest examination, TB analysis and all. No? You can, using X-ray image only, you can do that. So this is some of the abnormal things you can see here, like how the abnormalities visible here in a normal X-ray and a abnormal X-ray. And this is a mammography example, where you can see that breast cancer being detected here, where when the cancer is there in the breast part, you'll be able to clearly see the benign part and the malignant part. When it's benign, it is something non-dangerous. If it is malignant nature of the tissue, then it is cancerous. So they usually do a tissue biopsy from this region. They take out a small, they do a small incision and get this piece, tumor part, and then they send it for pathological examination, and then they decide whether it is benign or malign. So there are a lot of algorithms available. Even a lot of AI techniques, artificial intelligence techniques, are being used to look at these images and then detect whether it is benign or malign, because directly from the human eye you cannot make it out that it is really benign tissue, or not all tissues are cancerous. So that's why it requires this kind of classification. So we use AI techniques for mammographic cancer classification, even for TB and tuberculosis and other lung disorders. We use AI-based techniques. I think during COVID era, you would have heard about a lot of inventions happening, where a lot of demand was there for X-ray, because chest was heavily impacted during COVID era. So a lot of AI algorithms are developed at that time to detect the COVID cases, the severity of the COVID, grading of the COVID was done using a lot of AI techniques. So a lot of opportunities there to use digital AI techniques to do the detection of the diseases in the X-ray images also. So next comes one step ahead. We are going little complex system. X-ray is the most simplest system, because there is no much hardware involved. It has only the source detector, and then table where patient will lie, and then the digital imaging techniques to do the acquisition, sampling, and then doing AI on top of the images. Whereas now CT, if you say, it is a computed tomography, where it uses it has a rotating part, and it uses a source and a detector, which is in the combination. I'll just to show. I'm jumping by 2-3 slides here, just to visualize how X-ray CT is being taken. So fundamentally, it is also X-ray system. It uses X-ray, but it is moving. X-ray and detector, they are moving around the patient. So there will be X-ray gantry. We call it as a gantry. I think I might have some pictures. Okay, something like this CT gantry is there. I think something missing here. I missed to add a. So this kind of gantry is there. We call it as a gantry. Inside to that, there will be a X-ray source and detectors, which is moving together. Here it is shown, like here. So there is a source here and a detector here, and it is a circular structure. human will be subjected to lie on a table, and then table moves inside the gantry. It's like a donut shape. Inside, you'll be able to move inside and go in a horizontal direction like this, up and down. And this detector and source, they're paired actually. They're rotating like 360 degree. So you get the 2D slices at different intervals. It takes one shot here, and then it comes here. It takes one shot here, then it comes here, and then it takes one shot here. So whenever X-ray comes here, no, your detector will be the exactly opposite side. So they go in pair together. So and it goes 360 degree like this. You are able to get the complete 2D slices at a different time interval and at a different degrees. In 360 degree, you get a different views. So now actually technology is advanced. You need not rotate to 360 degree. Even with the 180 degree, you'll be able to get the complete picture due to the optimization. You are able to get the complete 360 degree view of things. So whatever the data you get out of this detector is again a electrical signal. It's getting digitized. Continuous signal will be digitized, and then you get a 2D slice. So when you stack it together, it makes a 3D slice. And then we use some reconstruction algorithm to get the actual internal organ picture. So like this, I'm just showing a head CT. Sorry, this is abdomen, CT of the abdomen. But here I'm showing the CT of the head. So this is a CT scan of the abdomen. You can see that stomach, liver, and kidney, vertebrae. This is spinal part. This is a posterior part, and this is the anterior part. Anterior means the front side, posterior means back side. And you can see a spine running. This is a bread slice. You can assume whatever I gave example, no? That one slice from the stomach, if you cut it open, no? Using a knife, how it will look like. So that's what the view we are showing here. We call it as a axial slice. So you're cutting it vertically and then getting one piece out of the stomach region. So imagine as if you're cutting using a knife and getting one small slice of 2 mm, 3 mm slice from the stomach area. That's how the image will look like of the stomach. And if you see the head part, no, this is a cranial scanning. We call a brain scan. So you can see that the head scan. This also has different cuttings from your chin area to the top of the head. Vertically, you are getting cut into different pieces. So it is nothing but you are getting the projection of the images in different direction and then stacking it together. I'll just show a stack. So like this, how it happens, I'm just jumping here and there to explain you better. So this is how the stacking happens. This is the Z direction, and this is X and Y direction. So you are stacking it together, and then you get a beautiful picture by doing a lot of reconstruction algorithm. So you can generate any view. Once you get one particular view, using computer graphics technique, you will be able to get any views from the one view. So that is a reconstruction algorithm. So typically CT use it for looking at the hard tissues and bones, whenever the accident cases, the trauma cases and all, or any bleeding cases, those are visualized good with the CT images. So the moment patient brought into a CT room, he will be asked to undergo some of the preliminary checking, and then he'll be subjected to scan, and then he'll get a CT scan. So it can be for any scan. It can be brain, neck, or chest. Even if it's accident case, it can be a whole body scan because they don't know where exactly the issue. So they need to check at all the body parts. So it can be very specific to a particular organ, or it can be a whole body scan also. So depending upon the purpose, they decide what kind of protocol they need to select. We have something called a protocol, which defines particular scan parameters for a CT. Because CT works on the principle of X-ray, right? So you need to know how much dosage has to be given and what is the frequency. All those things has to be decided. So those protocol decides the parameter. So that protocol depends on what kind of scan is subjected. If it is a brain scan, then parameter is different. If it is a neck scan, it is different. Chest is different. Abdomen, pelvis, knee, lower abdomen, all those things varies. And it can be a whole body. When an accident happens, they don't know, right, where actually injury might happen. So they'll put some full head to toe, they do the scanning, whole body, and then they look at each image and then see where exactly the issue is, because patient may not be able to talk and tell where exactly is facing. He may be in the coma case also, maybe they are not, they will be unconscious, they cannot talk. So then they do a whole body scan and then identify where is the issue. And coming to the, okay, this is the visualization of the data, like how the cuttings happens in the vertical slice. You can see that axial slices are getting cut here, and then they are stacked together, and you get a beautiful picture of a thigh to chest area. If you see here, it is getting the complete view of the organ. So this we call it as I think we have coronal. This is a coronal view. We have 3 views here, and the medical terminology, we call it as in different ways you can cut the human body using a knife. If you imaginary, not really I'm telling. If you imaginarily, if I'm telling, sagittal is cutting like this. You are cutting from this direction. Coronal is cutting from nose to the back of the head. That is coronal cutting. And then axial cutting is cutting from chin to the top of the head. So you get one slice like this. So this is actually the slice here, and then how the CT image of that particular anatomy is visualized here. Similarly, if you do a coronal slicing, actually not cutting happening using a scissor or knife here, it is actually cutting using the imaging techniques. You are getting the different projection, and that projection image we are showing here, and using this cutting technique, we have a lot of algorithms and tools available in the post-processing software where doctor can choose a different software to do this analysis. He'll use a lot of image processing tools in his computer to get these views. So this is the typical examples of a color coded, or we call it as a rendered. This is called computer graphics rendering. Actual original image is actually not like this, but we use a lot of computer graphics techniques to put color and get data. Actually, whatever the data we get is gray color from the pixel value. Once the scan happens, once you get a picture, that pixel value is nothing but a grayscale image. But we use computer graphics techniques to make it more visualizing by applying different colors, make it RGB, so that doctors can see this better. Because raw images, doctors cannot make any sense out of that. So we use computer graphics, post-processing techniques, and visualization tools to get this kind of view. He can cut in any oblique plane also. He can cut in the computer graphics. You can cut in different directions, see what is there inside the brain. Where is the brain damage? Where is the bleeding happening? Where is the hemorrhage happening? All those things are visualized using this medical imaging techniques. So this is the aortic stent example where you can see that aortic wall which goes from heart to the till toe, one main blood vessel goes, that is called aortic. Sometimes there is a blockage happens here in this region causing problems. So we need to put a stent, like how you put stent to the heart, like that they apply stent here to avoid the blockage of the blood. So we use the stenting techniques even for heart and other aortic region. And different views you can get in any projection images you can get. And coming to the clinical use, it is one of the go-to technique to get the internal picture of the organ, and it is very fast compared to MR. CT scanning is very fast. It takes around 4 to 5 minutes or 6 minutes. X-ray is less than a minute. CT is around 4 to 5 minutes, depending upon the protocol. If it is a whole body, it might take more than 5 minutes also. But otherwise, it is less than 5 minutes. And it is radiation exposure is there. So this is the advantage of the X-ray, because X-ray is not good for human body. It's ionizing radiation we call, and it gets into human body. Our cells get impacted, and long-term exposure to X-ray may cause cancer. So that's why people who are going to CT room, you should wear the CT apron. Aprons are something like a special dresses which avoids X-ray penetration to your human body. Most of the time, they don't allow anybody to get into the CT and X-ray area. Especially the pregnant women, they are not supposed to go, and even the normal patient also, they should not go to X-ray and the CT unless it is prescribed for a treatment. And that's why it is dangerous to human body. Having too much of X-ray radiation might cause injuries to the human body. That's why you should avoid as much as possible. But clinical purpose, it is certified, and it is okay to get exposed for treatment purpose, but not for a continuous duration. And it is used in the surgical room also. Nowadays, they are using the surgical purpose. You get X-ray, like the angiography, whatever the cath lab procedures which is happening for the cardiac stenting. When the heart attack happens, or when people experience breathing difficulty, they send them to cath lab. Cath lab is again a CT machine. It is a small CT, but not like a full-fledged CT. So CT-like imaging it is actually. So they get intervention done. They send the needles and balloons and catheters through the blood vessel, and they analyze using the X-ray monitor where exactly the blockage in the heart. So using X-ray technique, they are able to find the calcification, because calcium is opaque to X-ray. So whenever the calcium plaques are formed in the heart blood vessels, you'll be able to see the blockages. So we use this cath lab products to do the angiography, and once angiography is done, they know where exactly the heart block is, how much percentage blocked is visible using this X-ray technique. And then using X-ray guidance, they send the catheter or the balloon depending upon the type of the treatment. If you are sending balloon, you are rupturing the blockages inside the blood vessel and opening the blockages, then the blood moves inside your heart and the patient will be relieved. And sometimes they put catheters. When you say catheters, it is a permanent structure which will be staying inside the blood vessel. It will be lying on the blood vessel walls, so that it will not be blocked further. So they do the ballooning technique to open the blockage, and then they fix the stent so that it will not be blocked in the future time. So that's why they use both techniques. For all these things, they use CT and X-ray guidance. So this is a brief summary of X-ray and CT imaging modality. Next, I'll go to one of the next complex scanning device in medical imaging industry is MR. MR stands for magnetic resonance imaging. So in X-ray and the CT, I told it is X-ray physics, which is straightforward. Whereas in MR, it is little the physics involved in designing this product, it is a little totally different. So here actually you might have studied in your physics, the resonance techniques. When the human body is subjected to magnetic field, the hydrogen atoms in the human body, they do the variation happens, the rotation happens, they do the orientation changes, and then the reorientation happens when they subject the radio waves. And when that transition, that resonance happening time, they do the signal acquisition and they get the MR signal out of that, and that is being captured as an image. So they use very high field magnet, because human body contains 60% of the water molecule in the human body. So that water has hydrogen and oxygen, H2O. So that hydrogen molecules are being used for orientation during the magnetic resonance time. And using that principle only, we will be able to get the beautiful picture from the MR scanners. So they use very high, like 1.5 Tesla. We measure magnetic field in Tesla, right? So that's why even the X-ray MR products are classified based on the magnetic strength. It can be 1.5 Tesla scanner, it can be a 3 Tesla scanner, now even 7 Tesla also there. So it's a very huge magnetic field actually. That's why a lot of care has to be taken when people are undergoing MR scan. So there will be MR magnetic field, and also the radio is getting applied using the coils, and then orientation happens and we get the signal out of that. So the important thing that where the patient should not have any metal implants when he's undergoing magnetic MRI scans, because of magnetic field, it will be damaged or it will be injurious to the patient. And even the magnetic materials like tables, chairs, oxygen cylinders, that should not be taken inside magnetic field, because this scanner gantry, it is made out of liquid helium, and then that generates the electromagnet, and then due to that electromagnet, you get 1.5 Tesla magnetic field inside. It is a very huge magnet field, so it will be immediately attracted by the scanner, and if the patient is undergoing scan, it will damage even the human patient. So a lot of cases happened where patient died due to ignorance of the caretakers, where they are taking oxygen cylinder, or recently in Mumbai hospital, you might have heard a few years back, one patient died due to the attendant took the oxygen cylinder inside the MR room. So that's why that kind of things should be avoided when patients undergo the MR scan. But from the patient point of view, this is most safest scan, because there is no ionizing radiation, and it works on MR magnetic resonance things. That's why it is not dangerous to the human anatomy. You can undergo MR anytime and as much as time you want. And even the attendant, the caretaker of the patient, also can go inside the scan room. So they usually make the patient to lie on the table, and then they put some coils, this head coil, chest coil, knee coil, and extremity coil. They put that coil. That coils are localized to the region where you are scanning, and then radio pulses are sent through the coil to the localized region, and this scanner detects the signal based on the magnetic resonance principle. Typically, MR is used for soft tissue scanning. Usually the blood flow is analyzed better here, and even the soft tissue is analyzed better, and also the brain changes, the functional imaging call, no? Very good. Actually, MR is very good for functional imaging. The MR is the go-to modality, the standard modality or scanner when neurological cases happens, when the people have the neurological disorders. It can be Parkinson or those kind of diseases, mental disorders or any head injury. Even the bleedings also can be visualized better. But the disadvantage is that it is a magnetic field is there, so you should be very careful when you go inside with the metallic object. The ferromagnetic material should not be taken inside the scan room. And then second thing is that it takes more time, because each scan will take around 15 to 20 minutes. For emergency cases, you cannot use MR because it needs 20 minutes or 30 minutes, even 45 minutes scan to get one set of images. So typically, when the diagnosis purpose, when you're not critical case and all, MR is suitable. But accident trauma cases, MR may not be that great because it takes 30 minutes, 40 minutes. So it is very important. Even for stroke cases, CT is the best thing, because CT scan happens in a few minutes and you will be able to save the patient better using those scanners. So it uses radio waves and also the powerful magnet internally. So these are some of the important, beautiful images which is coming out of MR. We can see that ankle images, brain images, angiography images, even the abdominal images using MR. Typically used for all neurology, angiography, and GI analysis. Neurology is all the neurological disorders. Angiography is for blood vessel disorders, and then GI is gastroenterology, the stomach inside any diseases. You'll be able to analyze it better because of the soft tissue richness in the MR scan. Even the tumors and abdominal things, osteoporosis, all those things are visualized better. Even the knee and even the orthopedic related things, are visualized better. For muscle tear and the ligament tear and all, they are visualized better in MR. So typically during sports injury, they recommend MR scan for ankle, knee, and hands, because you'll be able to see the internal structures better. And the functional imaging also better, where you can see when the human is thinking, the brain pattern changes, the chemical composition inside the brain, the activity changes, and those brain activity changes are visualized better using brain activity map in MR. So people will be subjected to look at the videos or images, or they ask to read some books and all. No? That time the human brain signal varies, and the signal coming out of the brain will be analyzed directly using MR image, and they'll be able to see if there are any cognitive issues, recognition issues are there. No? Those kind of issues are detected better using MRI scan. And we call it as functional imaging, because as and when human thinks, we get the images and then analyze the images. And next comes the nuclear medicine. It is again different. It is used along with the CT and MR also, where they inject radioisotope to the human body, and then they use gamma camera to detect the photons emitted out of the human body, and we use that signal to get the photon images using gamma camera, and we get the image. Again, this is used for the functional imaging and even for the cancer treatment, because the activity is being monitored using gamma camera is very good. Wherever the high radioisotope being absorbed more, that means that it is cancerous. So that's why they inject radioisotope. So before the scan, before half an hour or 1 hour, they give the radioisotope in the liquid form to drink, and the patient will be asked to lie in a room for 15 minutes so that activity starts inside the body. And once the radioisotopes gets absorbed by the blood, and through blood, when it goes to the different anatomical regions, this radioisotope gets absorption by the human anatomy. And wherever the cancer is more, that isotopes are absorbed heavily, and they emit more photons compared to the healthy part. So that's why if you find any this kind of image spots in the gamma camera in PET imaging, that is an indication of the cancer. So usually these PET images are used in combination with the MR or CT. It can be a PET CT scan, or it can be a MR CT scan. Sorry, PET CT or MR, PET CT or PET MR. Two things are used. Here, PET and MR, MR and CT used for localizing the region, and PET is used for the identifying the activity and identifying the cancer spread area. So this is the PET image, where you can see that patient is having some cancer kind of things in the brain, where you can see a lot of activity happening in the head region, And also in the abdominal region, you can see a lot of cancerous things are found. And even the kidney and urethra region, you can see the prostate region, you can see a lot of activities are being found. So that's why this PET image is fused. They're called image fusion technique. So they do a MR image or CT image where you get the anatomical details, and then they superimpose this image on MR or CT image, and then they get a PET CT image. So where you can see anatomy as well as the cancer together. You can see this is color coded for the presence of the cancer. And then comes the ultrasound. This is a little simpler modality, typically used for treatment of fetal analysis and then abdominal analysis and all. They use for analysis of these diseases. It uses ultrasound technology. Again, it's a different physics involved here, which uses high frequency sound waves, and based on the echo principle, we get the images getting generated. So you can see that it is being used for the fetal analysis. When the pregnant ladies undergo scan, they can see the different cycles. They can see different appearance of the baby in the womb. So that's why, and this is also very safe modality where it will not have any injury or negative impact to the human body. That's why they use ultrasound for fetal analysis. And even for the gallbladder stone, you can see in the gallbladder stone is being visible in the ultrasound scan. And even the Doppler effect for identifying the functional issues, they use Doppler imaging. And this is a comparison where it is useful and what is the advantage and disadvantage, which I already explained. And this is a pictorial representation, I think. And then comes to the format, how actually image being stored in the film format and the digital format. Film, I think you would have seen when you undergo X-ray or CT, they usually give the digital, the analog film, which will be carried out using a cover. No? And nowadays they give CD because you'll get it in a digital format, or you can put it on a computer and see the images better. Film technology is getting diminished now because of the storage issue, and then it will not be long-standing. It will not be. It will be subject to wear and tear and all. No? That's why visualization is not possible. If you have a digital copies of that, it will be stored for a long time. That's why nowadays all the medical image data is getting migrated to the digital format, and it is being stored in the archives for longer time. And these are some of the medical imaging standards. HL7 is health level 7, which is a standards given by the experts for managing the health data. And DICOM stands for the, which I already explained, which is used for storing the image data. So diagnostic image contents are being the radiology, RIS, and mainly the CT, X-ray, and MR images. They come under the area of DICOM because they generate images, and that is used in the algorithm purpose. And these are the storage format. It will have metadata, which stores the information about the data and also the raw data. So there will be DICOM library available in the public domain. You can download a DICOM library and practice this, download one DICOM image and then get into all the fields of the images. This is the PAC system, the picture archival and communication system. This is one of the important aspect in healthcare, how data is being stored and shared among the other people, because person who scanned in one hospital need not carry that data. It will be centralized and it is available in the central repository. A Manipal hospital scan done in Bangalore can be visualized by a doctor who is in Bangalore. He can also undergo scan in Bangalore KMC. He can migrate the data from Bangalore KMC to the Bangalore KMC because their data is integrated. There is a network of hospital due to the PAC system where the hospitals can be connected and you can archive and get the data from anywhere from the globe. So that is why you are able to get the data and analyze the data. A person getting scanned in Bangalore can be visualized and treated by a doctor in US because data can be transferred using network, and a radiologist in the US can give the prescription to a doctor in Bangalore who will be able to do the treatment. So it's called teleradiology, where we are getting decentralized and they are getting separated, and data can be shared anywhere in the globe and get the imaging perspectives. So these are some of the important aspects which I told in the beginning. Privacy aspect, because of the healthcare is very private information. Security aspect and regulatory aspect, because the country has a lot of guidelines how the data has to be stored and shared. And regulatory aspect, due to that. And interoperability, as I said, data should be shared across the hospitals, across the globe. So they need to follow the principle of interoperability. The image taken in one country can be taken and seen in another country. The scanner from one company can be visualized in another company's product. So interoperability. Performance, because of the healthcare, is very critical, and time is very important. That's why performance is also very important. And then IQ, we call it as image quality, is also important. Now I'm coming to the last slide. Some of the recent advances which is being now happening in industry. Mainly the scanners are made very smarter and faster and less exposure in case of CT. So a lot of invention is being done on the improving the scanning time, how you can effectively reduce the scan time, because critical patients are brought to the hospital, so they don't have much time and they need immediate result. They cannot wait for 3 hours and all, no, to get the scanning report. And also you need to identify what can be the innovation you can do to improve the acquisition faster and digitization faster, or the disease analysis faster. So we can use a lot of computer aided AI techniques to do the smart workflow in the hospitals, and a faster way of detecting the diseases using computer AI, digital AI techniques. That is one of the recent trend now. So most of the hospitals and IT companies are looking into those areas using computer aided detection called CAD technique. No, they are used for AI technology to detect the diseases. Then comes augmented and virtual reality, where you can have a 3D glasses or VR headset where you can traverse through the human body, like how you see in graphics movies. You know, similarly, you can wear a 3D glass and see inside human body. That is VR techniques, AR techniques. And then comes the 3D printers, where people are getting the 3D models of the human organ. They take the image scan from a CT and MR or X-ray, and then they develop a 3D model of the anatomy, and then they do the customized devices which can be implanted inside the human body. So for devising that implants, you need the 3D models. So that's why this 3D graphics and 3D printing is heavily being used now in industry. And then portable devices, how you can make scanners very small so that it can be taken to the patient's place. It can be home or to the road where patients are lying. You can go there and do the home scanning, home visits. So that devices are made compact and they're made more user friendly. And then comes the mobile IoT and wearable device, where you can make the device patient can wear like Apple watches and all. No, you can see the BP monitoring can be happening. The heart rate monitoring can happen. Even the activity monitoring and all. No, the fall detection. All those things are some of the invention which is in progress using wearable devices and IoT devices. We are able to do the remote monitoring of the patient. Patient being in a home, doctors can visualize at hospital after the discharge of the patient how he is doing at home. No, you'll be able to visualize using this IoT and wearable devices. A lot of companies are coming forward to do this kind of research and products for monitoring, remote monitoring of the patients. And then comes the teleradiology, which I already told, where doctors in India can get advice from experts sitting in the US or Europe, where you can send the images immediately using a PAC system to another country, and experts there can give guidance to the India. Or within India, an expert doctor sitting in Bangalore can detect the diseases in the smaller rural areas of Bangalore, can get scanned and data can be sent to Bangalore hospital, where a radiologist in Bangalore can visualize the image and share the prescription. So that is a teleradiology and telemedicine, which is actually coming up now. And then overall improving the patient experience and physician experience, because patients are coming with a very depressed condition. No? People who are sick, they are not in a good condition. When they come, their mood is in different set. So you should improve their mindset. It should not be give more inconvenience to the patient. So you should make the patient's experience better. And also the radiologist or physician, they are having very shortage of time. They cannot spend much time on the patient. So they need to improve the physician's time also. And one of the last thing which I'm highlighting here is evidence-based medicine and case-based diagnosis, where we are going with the evidence of the past patient. You'll be able to learn for the new patient using AI techniques. For a particular disease, the past treatment, what was the medicine given, how was the prognosis of the disease, whether it is ended in a positive outcome or it has ended in a negative outcome. Based on that, I can treat the present patient. So the evidence-based medicine is all about using AI technique to do the treatment of the patient based on the historical data. So these are some of the new trends which are being used now. A lot of inventions are happening. So I request you also to get into these areas, take up the some of the important applications of healthcare in your academic life, and take innovative activities and focus on those areas so that you get opportunities when you come out of the college. I think with that, I think AML is anyway, it's a very heavily used word for everything they use, starting from scan workflow automation, improving the image quality, or screening of the cancer, staging of the cancer, and then disease prediction, disease prognosis, and scoring purpose, and even further remote guidance and the device service purpose. Predictive maintenance of the scanners are done using deep learning models. And big data analytics is one of the important area where you have a lot of data in the hospital, but they are not being utilized properly, where you can use these analytics techniques to utilize those data and get some analytics and inference out of that. So with that, I conclude my session, and if there are any questions, I can take up.
Any questions, please? Any questions?
I will also share my email ID maybe later with the Satish sir, and you can also reach out to me through email if you have any specific things, or if whenever I come to the campus also we can discuss in person. For now, if you have any 1 or 2 questions, I can answer online as we have exceeded time.
So,
Can you hear me, sir? Sir, am I audible?
Or hello, am I audible now? There's a network issue here. Hello.
sir, am I audible?
Hello. Itakende, hello. Can you hear me?
Oh, we can hear you, sir.
Okay. Are there any questions for me? If not, maybe we can close the meeting.
Any questions, students? No questions, sir.
Okay.
On behalf of Department of Electronics and Communication Engineering and Electrical and Electronics Engineering, I would like to convey my heartfelt thanks to Dr. Hari Krishna for his enlightening and thoughtful provoking presentation on advances in medical imaging. Your expertise and insights into the latest developments in this field have been truly inspiring. The way you articulated the complexities and the future possibilities of medical imaging has sparked a new sense of curiosity and excitement about the future healthcare. We are deeply grateful for the time and effort you put into preparing this presentation and for sharing your valuable knowledge with us. We look forward to many more sessions with you in the future days. Thank you, sir.
Thank you. Thank you all.
Still, are you ready? Come. Next start is Puja. After